All right, for what we have in Aleks for section 2.5, okay, we have in the first problem, we're looking at graphing all horizontal and vertical asymptotes of the function. And we have, first of all, we have f of x is equal to negative 2 over x plus 5. And we have in the setup, okay, so looking for the vertical asymptotes, if there are any, okay, now we have negative 2 over x plus 5, okay, and this function is already in simplest form, okay, and we have in this case, all right, so we have for the domain now technically x plus 5 cannot be 0 for the function to be defined, okay, and we have that x cannot be equal to negative 5, okay, and for what we have in this particular case, all right, we have the factor from which negative 5 originates, okay, comes from the denominator, which we have at x plus 5. And since x plus 5 is not a factor of the numerator, okay, the factor, since it remains, signifies that the exclusion from the domain is going to become a vertical asymptote. Okay. And so in this case, we have for the vertical asymptote, okay, this will be at x is equal to negative 5. Now, in terms of what we have in the determination of the horizontal asymptote, now again, we have in comparing degrees, okay, we have for the degree of the numerator, we have that n is equal to 0 since we have no x term. And for what we have in the case of the denominator, okay, we have higher order term, we have an x which is of first degree. So we have the m is equal to 1. And we have from the relation in comparing n to m, we have the n is less than m. And if the degree in the numerator is less than what is in the denominator, we're going to have in this case a horizontal asymptote whereupon we have y is equal to 0. And so taking what we have, okay, so we have for the vertical asymptote, we have, again, have x is equal to negative 5. And for what we have in the horizontal asymptote, we have that y is equal to 0. And so checking what we have here. And the result is correct. Okay, for what we have in the second problem, we're still looking at vertical and horizontal asymptotes. Now, for the denominator, for the function f of x to be defined, you know, this cannot be 0 in value. So looking at the exclusion we have from x, it's going to follow that for x cannot be equal to negative 7/2. And since negative 2x minus 7 is not a factor of the numerator, okay, this expression is already in simplest form. So you will have a vertical asymptote where this exclusion is going to be, in this case, where the vertical asymptote, we have x is equal to negative 7/2. And going back to what we have in the layout for the horizontal asymptote, okay, so we have, in the case of the numerator, we have the n is equal to 1. Likewise, the higher order term we have to be first degree in x. So we have m is also equal to 1. And we have in the layout, okay, we have the n is equal to m. And for the horizontal asymptote, we want to have taken the ratio of the highest order terms. We have the higher order terms have negative 6x over negative 2x. And the horizontal asymptote becomes y is equal to 3. Okay, so lining up what we have here. Okay, so we have for the vertical asymptote, you have negative 7/2, so that's going to be negative 3.5. And for what we have in the case of the horizontal asymptote, we have that y is equal to 3. So just pressing, okay, and checking. And the result is correct. Okay, for what we have in item number 3, Again, looking for vertical and horizontal asymptotes. Now again, we have in the denominator, we cannot have 2x squared minus 2 to be 0 for f of x to be defined. Okay, and say if I factor, so I have 2 times the quantity of x squared minus 1, cannot be 0. Here we have a difference of squares. And looking at what we have with the x factors. Okay, so we have that x plus 1 cannot be 0, and that x minus 1 cannot be 0. So we have that x cannot be negative 1. We also had that x cannot be equal to positive 1. So in the case of the vertical asymptotes, we're going to have a couple of these. Since 2x squared minus 2 is not a factor of the numerator, the exclusions from the domain will be the vertical asymptotes. And again, looking at what we have in the degree comparisons, so you have in the numerator, you have n is equal to 0, and the degree in x in the denominator, okay, is going to be at 2. And for what we have in the relation, we have that n is less than m, and anytime the degree in the numerator is less than what we have in the denominator, we have a horizontal asymptote, which would be the x-axis, where we have that y is equal to 0. Okay, so in checking out what we have, so we have with our vertical asymptotes, we have x cannot be negative 1, x cannot be positive 1, and so we have, with our vertical asymptotes, have x equal to negative 1, x equal to 1. So again, these are exclusions from the domain of f of x. So these boundaries signify that we cannot have the function to allow the values of x at negative and positive 1. And again, for the horizontal asymptote, we have y is equal to 0, and checking out, and we had the result to be correct. Okay, for what we have in the fourth problem, okay, now we're looking at graphing the function. So just sort of expand. Okay, it says to graph the function, draw the horizontal and vertical asymptotes where they exist, and plot at least 2 points on each piece of the graph, and then click on the graph icon. So we have with our function, so we have f of x is equal to negative 6 all over x plus 3. So you have in the layout on this one. Okay, so we have that for the function to be defined, again, negative x plus 3 cannot be 0. And we have that negative x cannot be negative 3. And changing the signs, we have that x cannot be equal to 3. And since negative x plus 3 is not a factor of negative 6, okay, we have our vertical asymptote at x is equal to 3. And where the horizontal asymptote comes in, the degree of the numerator is 0. The denominator has a degree of 1. And so we have in the relation, we have that n is less than m. And so there's going to be a horizontal asymptote once again at y is equal to 0. So we have with the asymptotes. Again, so we have y is equal to 0. We have that x is equal to 3. And looking at plotting points throughout. Okay, so and we'll just have in the mix. Okay, so we just have with values of x. We have y is equal to negative 6 over negative x plus 3. All right. So we have this particular case, right? So I'm just going to pick out some values. Okay, so if I have like x is equal to 2, and we have for y, we have negative 6 over the negative of 2 plus 3. So you would have as an ordered pair, you would have 2, negative 6. And if I go with, say you have, say the x value is at 1, then we have negative 6 over the negative of 1 plus 3. So you have negative 6 over 2. So that would be at negative 3. So we come out to 1, negative 3. Okay. And if I were to go out even further, okay, so you have, if I go to, let's say, it says plot at least 2 points on the other side, okay, or each side of the vertical axis, so you have 2 points to the left. And if I go 2 points to the right, so if I go to x equal to 4, we have negative 6 over the negative of 4 plus 3. So I have negative 6 over negative 1, which will come out to positive 6. So we have 4, 6. Now if I go with x at 5, so we have negative 6 over the negative of 5 plus 3. So I have negative 6 over negative 2, which will be a positive 3. And we have with the order pair, so I end up at 5, 3. Okay, so looking at what we have and plotting points. Okay. All right, so we have just for the locations. Okay, so we have for taking what we have and plotting points. Okay, so we have 2, negative 6, plot point. And if we go with 1, oops, negative 3, plot point. And we have, say, next in line. Okay, so if I have 4 and 6, plot point. And in the case of what we have for the next, in case we have 5 and 3, plot point. Okay, and so just taking what we have now, so with the connection and checking out, the result is correct. Okay, for what we have in the case problem number 5, okay, we're looking at choosing the best matching graph for each of the functions. And for what we have in the case of our two functions in this problem, we have g of x is equal to 2x plus 4 all over x squared plus 2x minus 8. And now just looking at identifying what we have for the asymptotes. Again, we have for the vertical asymptotes, those will stem from the exclusions of the domain of this function. So again, we have x squared plus 2x minus 8 cannot be 0. And we have in the layout, okay, so if I were to factor, I have the quantity of x plus 4 times the quantity of x minus 2 cannot be 0. Now, neither x plus 4 nor x minus 2 will be factors of the numerator. Okay, so there'll be no cancellation. So technically, g of x is already in simplest form. So we have that x cannot be negative 4 and x cannot be at 2. And those excluded values will be the vertical asymptotes. Now looking at the degree comparisons, okay, so we have, first of all, we have in the case of the numerator, okay, we have 2x plus 4, from which n is equal to 1, and in the denominator, Okay, we have that m is equal to 2. And we have the n is less than m. And we have, in the result, okay, so we're going to have a horizontal asymptote whereupon we have y is equal to 0. Now, looking at what we have among the graphs, okay, so we have, again, so you have the vertical asymptotes, x equals -4, x is equal to 2. So -4, 2, horizontal asymptote, we have it y is equal to 0. So A is still in the running. B, this is out of the picture. C, okay, still in the running. And we have, for D, okay, we had the same vertical asymptotes, but we don't have the horizontal asymptote at y is equal to 0. E, don't have the perfect match. And in terms of all three asymptotes, F also misses the mark. So the possibilities can come down to A or C. And looking at comparing what we have here, okay, if you notice, we'll pick an x value that will have a distinct location for where the function will be situated. So if you notice, you have different y values where x is equal to 0. So we'll just say here that if I were to take plot a point, so have x equal to 0, we are corresponding y value. We have 2 times 0 plus 4 is 4. And then we have 0 plus 0 minus 8, so I have -8. And 4 over -8 is going to be -1/2. So a point on the graph of this function will be at 0 and -1/2. And it looks like here when x is 0, we have a positive value in graph C. And here we have 0 and what looks like -1/2 in graph A. So in this case, so C is going to be out of the picture. And so we're going to have graph A. All right, now, for what we have in the case of our function h of x, here we have 4 all over x squared minus 5x plus 4. And if we look at exclusions from the domain, so you have x squared minus 5x plus 4 cannot be 0. And looking at factoring, so we have that x cannot be 4 or 1. And since we have the factors are not also factors of the numerator, these exclusions from the domain will be our vertical asymptotes. So we have vertical asymptotes situated at x equal to 4. And also we have x equal to 1. And in looking at what we have for the degree comparison in the numerator, the degree is 0 since we do not have an x term. And in the denominator, we have the degree m is going to be at 2. So we have in the comparison, we have the n is less than m. And we have, in this case, we have a horizontal asymptote whereupon we have that y is equal to 0. And in terms of the possibilities here, that we have all three of these asymptotes. Okay, so where we have y equal to 0, you have graph A, graph B, graph C, as well as E and F. But where we had the vertical asymptotes to be x equal to 1 and x equal to 4, A is out of the picture, B is in the running, C is not, D is not, and we have E is a possibility, and graph F is also a possibility. And in terms of separating what we have here, so you have graph B, graph E, and we have with graph F, and it looks like for what we have situated. So if I were to try out 0, so like graph F, you have -1 for y, -1 for y, and you have a +1 for B. Okay, and we'll see what we have for x equal to 0. So at least one of these will go out of the picture. So you have x at 0, and 4 over 0 minus 0 plus 4. And in this particular layout, okay, so you have at 0, 1. Okay, so we were down to the graphs here. So we had graphs B, E, and F. Okay, so where we have 0, 1, that's going to be with graph B, whereas in case of graph E and graph F, okay, those will be negative terms. So E and F are going to go out. So we have for the choice, that is going to be graph B. So we have for the first function, again, the choice is graph A. And so we have just in taking what we have now. So we have, so for function G, okay, the choice was graph A. And for the second function, the choice was graph B. And checking the results here. And the result is correct. Okay, for what we have in the case of problem number 6, okay, we're looking at graphing all the asymptotes of the following function. So here we have f of x is equal to x squared minus x plus 5 all over x plus 1. And in the case of what we have for the domain, okay, so we have that x plus 1 cannot be 0 in value. And from this, we have the x cannot be at negative 1. And since x plus 1, from which we have the 0 issued for that negative 1, is not a factor of the numerator, x squared minus x plus 5, we have this exclusion from the domain to be the vertical asymptote. So we have the vertical asymptote at x equal to negative 1. So we have on the side of, well, we have at least for the vertical asymptote. Okay, so here we have placing, okay, so we have x equal to negative 1. And in terms of any other asymptotes, and now we have, and just bringing this to fuller view, okay, we have, in comparing what we have between the degrees of the numerator and denominator. So we have a highest degree term in the numerator is x to the second, so we have n equal to 2, and in the denominator, okay, we have from x, which is the higher degree term in the denominator, we have that m is equal to 1. And for what we have in comparing the degrees, okay, so we're going to have that n is greater than m by 1 degree. And from this, now we're going to have a slant or oblique asymptote. And for what we have in the case of the slant asymptote, now this will be arrived at if you have a linear denominator. You can use either synthetic division or line division. Okay, so we have for the slant asymptote, now we have y equals, and for what we have in the case of taking what we have with x plus 1, the divisor, into the dividend, which we have at x squared minus x plus 5. All right, so we have x into x squared is going to be an x, and distributing x over x plus 1, so we have x squared plus x, and taking the difference, again, with line division, you're looking at row by row subtracting, so x squared will go out, and we have what's going to be negative x minus x, so we have negative 2x, and we can bring down the plus 5, and x into negative 2x, okay, we have it minus 2, and distributing negative 2 over x plus 1, so we have negative 2x minus 2, and we have taking the difference. Okay, so we have 5 minus negative 2, so that is going to be at 7. And for what we have in terms of the quotient, okay, this would be the slant asymptote. Okay, so we're going to have that y is equal to x minus 2. Okay, so we're going to have, again, a slant line. And for what we have in the case of transferring, okay, what we have here. So we have with, again, the slant asymptote that y is equal to x minus 2. Okay, so we can plot some points here. Say we have on x minus 2, say if x is 0, y is going to be at negative 2. So we have with order pairs, so we have, in this case, so we have 0, negative 2. I can plot a point. And also if I have on the x-axis, if x is 2 and y is 2 minus 2, well, y is going to be at 0. And we can plot the point. And in joining together, okay, what we have here, so placing the first points I have at 0, negative 2, and also at 0, 2, and checking what we have with this function. The result is correct. Okay, for what we have in the seventh problem, it says to graph the rational function f of x is equal to 2x minus 3 all over negative x plus 3, and it says to graph the function, draw the horizontal and vertical asymptotes, if any, and plot at least 2 points on each piece of the graph. And then click on the graph icon. Okay, so we have with this particular item. Okay, so we have in this problem. Okay, now starting out looking at what we have with the asymptotes. Okay, so on the side of the vertical asymptote, so again, vertical asymptotes will originate from exclusions in the domain whose fact terms will remain after the function is put in simplest terms. So here we have negative x plus 3 cannot be 0, and if I take away 3, we have negative x cannot be negative 3, and so for we have excluded from the domain the value of 3, and so we're going to have a vertical asymptote at x is equal to 3. Now, in looking at what we have in comparing the degrees, so the degree of the numerator is going to be at 1, and from negative x, the degree of the denominator is equal to 1, and so we have, in comparing the degrees, we have that n is equal to m, and from this, now there will be a non-zero horizontal asymptote, and we're going to have that y is equal to the ratio of the coefficients of the highest degree terms from the numerator and denominator. And we have 2x over negative x, and this reduces to negative 2. So we have a vertical asymptote at x is equal to 3, and a horizontal asymptote at y is equal to negative 2. Okay, so in looking at plotting, okay, so we have x equal to 3, and we also have y is equal to negative 2. Okay, so we have the asymptotes. Now, in looking at plotting a couple of points on either side, okay, so what we can do here is that, okay, so you have x equal to 3, y equal to negative 2, okay, and in taking now again, so you have for x, you have y equal to 2x minus 3 over negative x plus 3. Okay, And we'll pick a couple of points of x less than 3 and a couple greater than 3. So let's say we have 1, 2, 4, and 5. Okay, so we have in this particular case, right, so we have for x equal to 1, so you got 2 times 1 is 2, minus 3, so we have negative 1. And you got minus 1 plus 3, so in this case we have y at negative 1/2. And taking what we have now with x at 2, 2 times 2 is 4, minus 3 is 1. The negative of 2 plus 3 comes out to positive 1, so we have that y is equal to 1, so we have 2, 1. And for what we have for x at 4 and x at 5, so we have with x at 4, we have 2 times 4 is 8, minus 3 is 5. And we have the negative of 4, which is minus 4 plus 3 is negative 1. So you have y at negative 5. And whenever x is 5, 2 times 5 is 10, minus 3 is going to be at 7. And we have the negative of 5 plus 3 is negative 2. So we have negative 7/2. Okay, so we have additional points. So we have at 4, negative 5, and 5, negative 7/2. And so just transferring what we have now. Okay. So you have for plotting points. So you have 1, negative 1/2, and also we have 2, 1, also we have 4, negative 5, and we have 5, negative 7/2. And plotting. Okay. Okay, so after plotting the points, I'm going to go ahead and X out. Okay. And we have just linking together. Okay, so you have with this little graphing. Okay, so testing out. And the result is correct. Okay, for what we have in the case of number 8, all right, so we have what will be excluded from the domain. Okay, so you have x squared minus 4x plus 3 cannot be 0. Okay, for what we have in the case of number 8, it says to graph the following rational function, where we have y is equal to 2x minus 6 all over x squared minus 4x plus 3. And now this is going to be a bit of a different item because this is going to be a graph that will have a hole in it. Okay, so again, we cannot have a 0 denominator, so x cannot be 1 or 3. And now this is going to be a different situation whereupon we're going to have a factor that will be shared between the numerator and denominator. And it's going to follow that in reducing. Then we have x minus 3 to cancel. And the 0 from a factor that cancels is going to be a whole. And taking what we have and reducing completely, okay, we have 2 over x minus 1. And here, okay, it's going to follow that for the vertical asymptote. This will be located whereupon we have x equal to 1. Now, in terms of looking at the degree comparisons, and taking what we have now, so you have for 2x minus 6 all over x squared minus 4x plus 3, the degree of the numerator is going to be at 1, and that of the denominator is going to be at 2. And we have the n is less than m, so we're going to have, in this case, there'll be a horizontal asymptote at y is equal to 0. And if we go ahead and look at points, that will be applying to what we have with this rational function. So we're going to have here, okay, so we have for x values, say we have, say you have -1, and if I were to reduce, okay, numerator becomes -8, denominator is going to become +8, and if I have x at 0, okay, we'll have for the corresponding y value, okay, the numerator we're going to have at -6, and the denominator becomes 3. So we have y is going to end up at +2. And in the case of taking what we have for x at 2, now we have in this particular case, we have for x at 2, we have y is going to be equal to -2 over -1, which will be +2. And if I were to go, now we're going to have a whole at x equal to 3. And just for another point, if I have x at 4, okay, so you have 2 times 4 is 8 minus 6 is 2. And we have 4 squared minus 4 times 4, that becomes negligible. And adding 3, so you have y is equal to 2/3. So for the ordered pairs that you would have here, with x and y, okay, so I have -1, -1, 0, 2, and also, okay, make that 0, -2. We have 2, 2, and 4, and 2/3. Now I'm just going to mention, okay, so if with x at 3, now y will be undefined, and you would have a hole in the graph. But I just want to mention, okay, now for the completely reduced form, I had y equal to 2 over x minus 1. And this would not be a solid point, but for x equal to 3, so you have 2 over 3 minus 1, so you have 2 halves, that is equal to 1. So in this case, you would have a hole located at 3, 1. And trying to apply what we have for what we have in the graphs. Okay, so we have just see if I can get this first. Okay, so you have a hole located at 3, 1. And if I plot points, so I have at -1, oops, -1, -1, and have 0, -2, also have it 2, 2. Also have 4. I'll just enter the fraction 2/3. And then equipping what we have with the vertical asymptotes. Okay, so vertical asymptote, again, we have x equal to 1. Oops. Okay, so I've already plotted the points. And just going back to the asymptotes. Okay, now I plotted the points and going back to the asymptotes. So you have x equal to 1, y equal to 0. Again, just placing the first piece. Again, just with our plotted points. Placing the second piece, we have one of our plotted points. So we have 0, -2. And we have checking the results. Okay, so it looks like we have everything in line. And that is correct.